This video is on radicals and rational exponents. Radicals and rational exponents, what we want to be able to do is to be able to convert between radicals to their rational exponents and then their rational exponents back to their radicals. Basically, a rational exponent, we're going to be using a fraction exponent, which will turn back into a radical. So x squared will not turn into a radical, but x to the 1/2 will turn into a radical. So we want to be able to convert them because if you don't have a calculator or if you are not allowed to use a calculator, sometimes it's easier to look at the converted version so that you can simplify it without the use of a calculator. So in order to convert, we might have a problem that looks like x raised to the a over b. So what you have is you have a base, a base of the problem. It's going to be raised to a fractional exponent. So what we do is we can convert this to a radical. So we have to keep all three of these things in here. Whatever your exponent is attached to needs to be combined inside of your radical. So your exponent of a over b is attached to the x. So we have a radical, and we're going to use all three of these things. Now, whatever is attached to your exponent is your radicand. So the x is attached to your exponent. Your x is your radicand. That's the inside of the radical. Then we have to figure out the index and the exponent. The index is always going to be your denominator of your fraction. So the denominator is b. So your index is b. Again, this is the number inside that nook. If not outside of the radical, so be very careful. It's not a coefficient, it's the index. Therefore, the last thing remaining is your a. The numerator of your fraction is actually the exponent on the radicand. Now, one thing you must remember is that in order for this to work, your b value has to be greater than or equal to 2 because you can't take a 1/th root. You can also rewrite this as, I'm going to show you another way of writing this. You can have the b root of x, close your parentheses, and then that is raised to the a power. That actually means the same thing. So if you see the parentheses with the a on the outside of the exponent, it means the same thing. But the reason we want to look at this is because sometimes it's easier to take the root first and then raise it to the exponent. Here, you would be raising the exponent first and then taking the root of it. Sometimes that's a lot harder to do. So if we look at our first couple of examples, it says to convert radicals to rational exponents or rational exponents to radicals, but do not simplify. So we're not going to be using our calculator. So we're just going to convert this. Now, since we have a exponent, that means we're going to convert it to a radical. Basically, if you see a radical, we want to get rid of it. If you don't have a radical, you want it. So that means we will have a radical. So we'll have our radical. We just got to figure out what everything is. So the 1/3 is attached to that 125. So all of that is attached. I'm going to circle that a little bit. That 1/3 is attached to that 125. So that 125 is your radicand. Then we have to find our index and our exponent. We have to use all three of these numbers. The index is always your denominator of your fraction. So the index is actually a 3. So this is the cubed root. And then the 1 becomes your exponent on the 125. So this is cube root of 125 raised to the first. In this case, it would be easier to write it like this because it's just raised to the first power. So it's really the cube root of 125. I'm not asking you to simplify it. I just want you to be able to convert them. Because you can, if you don't have a calculator, you probably couldn't do this in your head, 125 raised to the 1/3, but if you convert it in your head, it's the cube root of 125. Just so you know, the cube root of 125 is 5, because it's 5 times 5 times 5. 5 times 5 is 25, times 5 is 125. Example 2, you have a radical. That means we don't want the radical. We want to convert it, okay? So what we're going to do is we're going to take our radicand. Our radicand becomes the base of our exponent. So we have 25,102. It's going to be raised to an exponent. It's going to be a fractional exponent. So all of this is being raised to that power because all of this is in your radicand. The index is always the denominator of your fraction. So in the denominator, we're going to have an 8. And remember, your denominator has to be bigger than or equal to 2, so that's good. Now we need a numerator. We only had two numbers. Technically, we had an 8 and a 25,102. But if you recall, the exponent, there's always an exponent. That exponent would be a 1. So it's 1 over 8 is your exponent. On example 3, this one is where we have the parentheses, the cube root of negative 140, all that raised to the 6th power. So when we do this, you can actually write it. There's two ways you can write this. The first way I'm going to write it is we have that negative 140. Then it's raised to the 1/3 because that 3 becomes the denominator. That 3 becomes the denominator. But then this is still all raised to the power of 6. That's one way of looking at it. Now we have an exponent to an exponent, and that means we just multiply our exponents. So another way of looking at this is negative 140 in the parentheses, raised to the power of 6 times 1/3, so it'd be 6 over 3. Now, you do actually want to see your exponents if that can simplify. So this is technically in parentheses, because this was in parentheses. You want to keep using parentheses, because the entire negative 140 is being raised to a power. If you're not careful, if you only raise the 140 and not the negative, you'll get a wrong answer. This is negative 140 raised to the power of 2. Now, I'm not asking you to simplify the value, but 6 over 3 can be simplified down to 2. On example 4, we have 16 raised to the 2.5, or 2 5/10. We don't have a radical, that means we want a radical. But we have to have a rational exponent, meaning we want a fraction. 2 5/10 is not written as a fraction, but we can write it as one. This is the same thing as saying 16, and if we take our 2.5, go to our calculator, 2.5, and we do math, enter, we get 5 over 2. That's our fraction, 5 over 2. So it's actually 16 raised to the 5 over 2. Now that we have a fraction, we can turn it into a radical. So all the 5 over 2 is attached to that 16, all the 16. So in our radical, because we don't have it, our radicand is our 16. The denominator is always your index, so this becomes the square root of 16, and then the 5 becomes your exponent. Now this is the case where if I asked you to simplify it, it would actually be much better to take, instead of doing 16 to the 5th power in your head, it'd be much easier to do the square root of 16 in your head. So this is when having those parentheses around it would actually make it much simpler to use. Do you have to write it like that? No. But if I'm asking you to simplify it and with no calculator, this would be much easier to work with, because then we'd have 4 to the 5th power instead of 16 to the 5th power, because that would be ridiculous. Example 5. Again, we don't have a radical, so we want a radical. So again, you have to look to see what is the exponent attached to. The exponent is only attached to the x, so that's the only thing that becomes a radical. The 7 stays as a coefficient. The 7 is still on the outside of the problem. This part becomes your radical. So we have a radical. The 2/3 is attached to the x, so the x is your radicand. And then, again, the denominator is always your index. So your index is 3, and your exponent is squared. So we have 7 times the cube root of x squared. So again, it's very important to see if you have parentheses or no parentheses. On example 6, we have parentheses, and so this exponent is actually raised to is on all of that. But there is a negative exponent, and we know we can't have a negative exponent. So the first thing we got to do is put this in the correct format. So this negative 5/4 is attached to all of that. So that entire thing needs to go to the denominator of a fraction. So it's 1 over parentheses 5x, because that doesn't change, raised to the positive 5/4. Now we can put it into a radical form because we don't have a radical, we want a radical. So it's 1 over, since all of this is inside parentheses, we have one radical. Your radicand is 5x. So because your radicand is in parentheses, you want to put parentheses on here as well. Your denominator is your index, so we have the 4th root. And then our exponent is 5, so we have the 5 right here. And that's how you would simplify that one. Not simplify, you would convert that one. You have to be careful about your negatives. And again, on like number 4, you have to be careful. If you have decimals, you have to convert it to a fraction. On these next examples, we're going to simplify and we're going to round to the nearest hundredth when necessary. That means we can use our calculator. Okay? Or if we can do it in our head, do it in your head. But I will show you how you can put this in your calculator. So this is 25 raised to the 1/3. So if I just take 125 raised to, so my little caret key underneath the clear. The thing is because you have a fraction in your exponent, you have to make sure you put parentheses around your fraction. 1 divided by 3, close parentheses. Now, if you have a newer calculator, if you do the caret key, it'll automatically put it up into the exponent, and you don't have to worry so much about your parentheses. So I'll show you on my newer calculator. If I do 125 and then the caret key, it actually turns it into an exponent, so the 1/3 will stay in your exponent. But on this one, if I don't do the parentheses, the 1/3 won't completely stay in the exponent. So if I press enter, I get 5. If I press enter on this one, I also get 5. Okay. If I did 125 raised to the 1 divided by 3 like that with no parentheses, I get 41/6700. Because what's really happening is the 125 is being raised to the first power, and then that's being divided by 3. So it's really 125 divided by 3. That's where that came from. That's why parentheses are important. So if you have a newer calculator, you don't have to worry about that as much because your 1/3 actually stays inside the exponent. So the answer is, in fact, 5. So I am going to write a little note on here again that it's that 125. And it's always good to even put the base in parentheses as well. Caret key, parentheses 1/3, close parentheses. And that is, in fact, equal to 5. You do not have to round it because it is a whole number. It's an integer. Okay. The next example, number 2, is the 8th root of 25,102. So we can use our calculator. So in a previous video, I showed you how to do the roots. If you go to math and you go to number 5, you can put in any root you want. So I just have to go back over here and put the 8 inside of that. And then I'm going to come over and put in the 25102. I'm going to press enter. I get 3 55/100. So this is approximately 3 55/100. On part 3, we are simplifying multiple things. So don't do it as one huge problem because we have numbers and letters. So focus on the numbers first. The square root of 64, the square root of 64 is 8. Not the square root of 8, it's 8. So we put 8. This would go to 8 times. And then we have, again, exponent rules. You have a power raised to a power. So this is 4 times 2/4. This is x raised to the 8/4, which is 2. So then our answer is just 8 times x squared, which is 8x squared. That one didn't have much to do with it. So we have 8x squared. We don't have much in regards to having to convert anything. Example 4, again, also goes back to exponent rules. 7 to the 1/2 times 7 to the 1/2. If you go back to exponent rules, we have the same base. That means that we can actually keep our base. And then we can add the exponents. This is 1/2 plus 1/2, which is really 1, so it's 7 raised to the first power. So that's just equal to 7. You could also have converted them. It would have been the square root of 7 times the square root of 7. So that square root of 7 squared is just 7. You can also put in your calculator 7 raised to the 1/2 times 7 raised to the 1/2, and you get 7. So you end up getting the same answer either way you do them. The last ones are simplified without the use of a calculator. So what we're going to do is, if we don't have a calculator, we have to convert it so that we could actually try and do these in our head. So the first one is parentheses -27 raised to the 2/3. So I can't do an exponent of a fraction in my head, so I'm going to convert it. So if I convert it, I want to put it into a radical. My entire radicand is -27. My index is 3, and I have a square. Now, I put that square on here, but I don't want to do -27 squared because that's too large of a number. So that's when I would use my parentheses around my radical, because I can take the cube root of -27. What times itself 3 times gives us -27. You can take the cube root of a negative, okay? Because for a cube root, it's a negative times a negative gives us a positive, times a negative gives us a negative again. So we can have a negative. So this will give us a negative. So it's 3 times 3 times 3 gives us 27. So the cube root of -27 is -3. And then we square that. Now -3 times -3, since it was in parentheses, is a +9. And we can check that in our calculator. So if we do parentheses -27 raised to the 2 divided by 3, we get a +9. So just checking in our calculator works. Okay. On number 2, I want to simplify this by converting it. So I'm going to convert this. All of this is raised to the 1/3. So I have a fraction, so I want to turn it into a radical. All of this is inside my parentheses. So it's parentheses 24, a to the 4th, b to the 6th, c to the 12th. The index is 3, and it's all raised to the first power. So basically, I don't have to put another exponent on there. But I've just got to simplify, and this just goes back to simplifying radical expressions. So the cube root of 24, well, I can't do that without a calculator. And if we think about it, let's see. The cube root of 27 was 3. So if we do 2 times 2 times 2, that would only give us 8. So basically, the cube root of 24 will give us a decimal, and I can't do that without a calculator. So I have to simplify the letters. So we go back to all those letters. We do a is 3 goes into 4 one time with a remainder of 1. So we have a to the 1st, the cube root of a to the 1st. B, we do 3 goes into 6, goes into 2 times remainder of 0. So we have b to the 2nd. And then for C, we have 3 goes into 12, 4 times with a remainder of 0. So we'll have c to the 4th with no remainder. So our answer, because we couldn't do the cube root of 24, that will stay in our radicand. So ignore that for a second. All of our coefficients. A to the 1st, b to the 2nd, c to the 4th. And then we still have the cubed root of 24, because we could not simplify that, and then a to the 1st. And that would be our final answer. Because cube root of 24 will have to give us a decimal, because 2 cubed gives us 8, 3 cubed gives us 27. That's in between those, so it's a decimal. The last example here, number 3, is all of 64 x, y to z to the 5th, all raised to the 1/2. So again, we're going to convert this into a radical. So we have 64 x, y, z to the 5th. The index is 2, and our exponent is 1. So all this is raised to the 1st. So I can simplify these as we go. So the square root of 64 is equal to 8. So that's my coefficient for that. Then for our x, we have 2 goes into 1, 0 with a remainder of 1. That means we still have the square root of x to the first. For the y, our index is 2, goes into the y exponent of 1. 2 doesn't go into 1, so it goes 0 times, still with the remainder of 1, so that 1 stays as it is. So this is the square root, because the index was 2, y to the first. Then we have z. The index is 2, goes into z to the fifth, so it's 5. 2 goes into 5 2 times with a remainder of 1. That means we have z to the second as our coefficient, and then we still have a radicand of z to the first. So our final answers. So we have all 4 parts to it. Our coefficients are 8 and z squared. So we still have radicals left over, so that means our index is still a square root. And then all of our radicands. Nothing, x to the first, y to the first, z to the first. So x, y, z. Those are all of our radicands. So we were able to do this without the use of a calculator. This is the one where we could check it because it's just numbers. And then we can check the square root of 64 is 8. And we could take the cube root of 24 is going to be a decimal. So if I do math, come down to 4, cube root of 24 is in fact a decimal. And I couldn't have a calculator, so I should not have decimals in my answers. And this is converting so that you can simplify them. You will want to be able to convert them so you can simplify them without the use of a calculator. Okay, so again, converting, your base is always your radicand. Your radicand is always your base. Your index is always the denominator of your fraction. And remember, it cannot be smaller than 2. And then your exponent is the numerator. And sometimes your exponent is better written on the outside of the radical completely so that you can do the math easier than trying to square something or take to the 5th power and then taking the square root. Sometimes that's a lot harder. So sometimes if you look at it, if you're simplifying and you can do part of it in your head, put the parentheses around the part you can do in your head.